Hello, my name is Jordan Anderson, and I'm going to be talking to you about the digestive system. To begin, we're going to talk about the anatomy and enzymology of fat absorption. So to start, fat digestion is complicated because most lipids are not water soluble. So as a result of this, the aqueous chyme leaving the stomach contains a coarse emulsion of large fat droplets, which have less surface area than smaller particles. To increase the surface area available for enzymatic fat digestion, the liver secretes bile salts into the small intestine. These bile salts help break down the coarse emulsion into smaller, more stable particles. And then enzymatic fat digestion is carried out by lipases, which are enzymes that remove two fatty acids from each triglyceride molecule. The results are one monoglyceride and two free fatty acids. The bile salt coating of the intestinal emulsion complicates digestion because lipase is unable to penetrate the bile salts. For this reason, fat digestion also requires callipase, which is a protein cofactor secreted by the pancreas. Callipase displaces some bile salts, allowing lipase to access the fats inside the bile salt coating. Lipophilic fats, such as fatty acids and monoglycerides, are absorbed primarily by simple diffusion. They move out of their micelles and diffuse across the enterocyte membrane into the cells. Experiments now indicate that cholesterol is transported across the brush border membrane on specific energy-dependent membrane transporters, including one named NPCJLJ. Once inside the enterocytes, they move to the smooth ER where they recombine into triglycerides. So for the enteric nervous system, there are two types. There's the short reflex and a long reflex. For the short reflex, that breaks into the enteric nerve plexus and the submucosal nerve plexus. The enteric nerve plexus is in the gut wall and act as a quote, little brain, allowing local reflexes to begin. This allows the local reflexes to be integrated and end completely in the GI tract, and reflexes that originate in the enteric nervous system and are integrated there without outside input. The submucosal plexus contains sensory neurons that receive signals from the lumen of the gut, and then the ENS network integrates this sensory information and initiates responses. The submucosal plexus controls sensory and GI epithelial cells, and then myenteric plexus neurons in the muscularis externa influence motility. And then although the ENS is allowed to work in isolation, it also has the long reflex, which communicates with the CNS. So the long reflexes that originate outside the digestive system include feed-forward reflexes and emotional reflexes. Feed-forward reflexes begin with stimuli such as sight, smell, sound, or thought of food, and they prepare the digestive system for food that the brain is anticipating. For example, if you're hungry and smell dinner cooking, your mouth waters and your stomach growls. That's an example of the feed-forward reflex. An example of an emotional reflex would be the emotional reflexes influence on the GI tract would be like the responding to emotions such as butterflies in the stomach or psychologically induced vomiting and diarrhea. The regulation of the gastric phase of digestion begins with gastrin, and gastrin is a hormone that is secreted into the blood, and it is stimulated by the presence of amino acids and peptides in the stomach or coffee, and it's triggered by neural reflexes and gastrin-releasing peptide GRP. Primary action is to promote acid release by acting on parietal cells and indirectly by stimulating histamine release. Parietal cells deep in gastric glands secrete gastric acid into the stomach, and then the acid secretion averages 1 to 3 liters per day and create a luminal pH as low as 1. And some of these functions include causing release and activation of pepsin, triggers somatostatin release from D cells, denatures proteins by breaking disulfide and hydrogen bonds that hold protein in its tertiary structure, helps kill bacteria and other ingested microorganisms, and inactivates salivary amylase, which stops carbohydrate digestion that began in the mouth. The roles of the pancreas is to secrete both insulin and glucagon. Insulin tells the cells throughout the body to take glucose out of the bloodstream, and it's used in order to keep the body's balance of glucose and blood concentration. So it tries to balance out blood concentration or glucose concentration in blood, and this is because blood travels to the cells of the body and it causes the glucose concentration to drop, and too much glucose can be harmful to cells, so it tries to keep the glucose levels balanced. And then glucagon counteracts insulin because too little glucose in the body would also be bad. So what it does is it signals the liver and the muscle cells that store glycogen to release it into the bloodstream, and this increases the blood glucose concentration. And then the role of the liver is to do, as I brought up with the glycogen, but it also secretes bile from hepatocytes, creates bile salts, which facilitate enzymatic fat digestion, which we talked about earlier, and finally the liver does glycogen, which we also talked about earlier. And that is the end of the video.